Okay, today we're going to talk about imaginary numbers and operations of imaginary numbers. Our first example here, notice that we have a couple of imaginary numbers. Imaginary numbers are ways to represent the square root of -1. The square root of -1 equals I, -1 equals I squared, and negative square root -1 equals I cubed. So essentially we're just going to look for different values of I squared, I to the third power, and substitute those values in. For example, the square root of -9 could be rewritten as the square root of 9 times I. In other words, we're going to pull that -1 out of the square root symbol. And then I is just I, so we'll leave that alone because there's a real and imaginary component usually. Square root of 5 and -2 are real numbers, so we're going to put those together by themselves. Then we're going to take the imaginary numbers, factor out the I, and then simplify their coefficients. So the first part are the real numbers, and the second part are the imaginary. That's why they have I. If you look at that, the square root of 9 is +3. That's the principal root. So then we have -3 plus 3, which actually becomes 0i. Well, we can choose to write down the 0i, or we can leave it alone. Likewise, to the left, the square root of 5 minus 2 is the real component, and it's an exact value. You might be wondering, what about the square root of 9? Could we take the negative root of this? Well, mathematically, yes, we could take the negative root of 9, which would be -3, and that would yield a -6i. However, when we deal with imaginary numbers, we primarily focus on the principal root. Of course, it depends on the application. So basically, what we end up with as our answer is the square root of 5 minus 2. Let's do another example. In this particular case, we have I squared and I cubed, so we need to remember the different values of I depending on their power. Wherever there's an I squared, we're going to plug in a -1. Wherever there's an I cubed, it's negative square root of -1. Now I did this on purpose because we know that the square root of -1 is actually I, so that becomes -I. So then we have a bunch of real numbers and then I left over. If you add up all the real numbers, we're left with -5 plus I. That's pretty much it. Here's another example for problem number 8. If I take, basically it's the same as before, remembering the properties of I, square root of -1 is I, -1 equals I squared, and this time we'll think of -I being equal to I cubed. We just go through wherever there's a certain power of I, we remove it. If there is a negative square root, we pull out the negative. And when we're done, we add up all of the real numbers and leave the imaginary parts by themselves. Now, to get an exact value, we do not approximate square roots. We just leave them as they are. So square root 7 minus 7 plus 9i is the answer. For problem number 14, we're going to find the product of two imaginary numbers. And here it's just a FOIL method to distribute all of the numbers through the different parentheses. I'm not going to simplify in the beginning, although you could if you wanted to. But essentially, we're just going to multiply the row by the column and then combine like terms and simplify, and that should give us our answer. So right now we have 6 root -4 minus 5 root -4i plus 6i minus 5i squared. Remembering our values for I and I squared and the negative root 1, if we simplify, we end up with 5 plus 8i. Remember, we always want to put that real component first and the imaginary component last. But the overall combination of the two is the imaginary number. Let's do another example. For problem number 15, we're going to be given two imaginary numbers. We're just going to distribute them through because we're finding the product. In this particular case, it's a little easier because we just have two like terms in the middle. We're going to substitute I squared with -1. When we combine all of the terms, we end up with 5 minus 10i.